So now I did want to discuss briefly graphs of integral defined functions. Uh, First off, how we could graph an integral defined function. There are a few ways of doing it. So let's say that we're given the function, the integral from 3 to x of t dt. Remember, t is a dummy variable. X is our actual variable here. One way we could do it is by hand, where we actually go ahead and evaluate the integral and say, well, this would be the same as taking 1/2 t squared. New notation here. This bar means that I'm going to be plugging in a lower bound of 3 and an upper bound of x and subtracting them. So it just means this is my antiderivative. I'm going to be plugging in x, plugging in the 3, and subtracting. So that'd be 1/2 x squared minus 9/2. And then this is my function. And that we know how to graph because that is a parabola where it's a vertical shift down of -9/2 to the -9/2 on the y-axis. Gotten a little bit wider, but parabola still opening up, and there's our graph. Alternatively, we could graph this on the calculator, and we can do it just by typing it in as an integral defined function. One thing to note is your calculators do not use dummy variables. So if I wanted to graph the function that's the integral from 3 to x of t dt, where t is a dummy variable, I don't use t. I still keep using x. So don't use dummy variables, just keep using x. So the other part of this is kind of, what if we're already given the graph of an integral defined function? And so here, I'm given a graph of f, and I want to say things about h. And all I'm told is that h prime is equal to f. So in other words, I am looking at a graph of h prime. This is the derivative of h. So if I wanted to talk about h itself, that means h is the antiderivative of f, or the integral. And I can even think of it in terms of an integral defined function in that I'm told h of 0 is equal to 0. In other words, when x is 0, y is 0. So if I wrote this in integral, h would be the integral because it's antiderivative of f. T is my dummy variable, x in the upper bound. I'm told that when x is 0, y is 0. And here's my function for f. So now if I wanted to find h of 1, I'm really finding the integral from 0 to 1 of f. Well, on my graph, that would be equivalent to the area between my function f and the x-axis from 0 to 1. And I can't find it exactly since I don't know exactly what f is, but I can estimate it because this is almost a triangle with a base of 1 and a height of 1, so this is going to be about 1/2. But then I can also find and justify extrema because this is a graph of h prime. It would have a relative minimum at 0 because h prime is positive, h is increasing to the right, because remember, this is h prime. I would have a relative maximum at x equals 4 because h prime changes from negative to positive, or h is changing from increasing to decreasing. And it would have a relative minimum at 8 because to the left of it, h prime is negative, h is decreasing.